instead of right now, which is 1, 2, 3, 4, 5, and 6. This is because the append function attaches number right at the end of the list, just like the stack that we discussed. The things at the bottom would remain on the bottom, and new items would be stacked on top of that. That's how the append function works. Now, similarly, if you want to remove an element from the list, we use the remove function, which you can see on line 12. Its usage is very similar to the append function. We use a variable name dot remove function and write the digit that we want to remove. So in this case, you write any digit in the list that you want to remove. We want to remove 3, so you can see in line 13 where we print that the output here shows that the number 3 has been removed from the list. So that is basically all the basic operations that you might require in setting up lists. Now, that is basically the core functionality that the Python creators built in to replace arrays within Python. But lists, while being more flexible, cannot deal with large chunks of huge. They can deal with large chunks of huge data sets, but when you deal with such large amount of data, there comes a point that every second matters, every amount of resource being consumed matters, and at that time, lists are much less efficient than arrays. And to handle that core fundamental problem of the lists, so somebody created the array library in Python, through which you can actually access the array data structure directly. I mean, it's 99% exactly uh, the same as lists, but the difference is behind on the back side of these uh, of these of these structures. But we won't go into that because that is completely out of the context of what we're trying to do, even as outside the context of being a master at becoming a master at Python, because that relates to compiling and compilers, so on and so forth. So let's focus on arrays. So to work with arrays in Python, first, as this is an external library, not a built-in function, you need to import the array function from the array library. Once you do that, as you can see on line 1, we move to creating an array of integers. Now, all other operations of the arrays are similar to lists, but this portion is different, because when you initiate a variable in line 4 here, you notice that I called the array function within which I have 2 arguments. And this is because that's the syntax that the developers who created the array library decided on. Usually, you won't need to set up an array like this, but here we need to set it up like this. For example, in C, uh, you might need to define the you might need to define the variable type before you define the data structure. So the language automatically understands what data would be within the array. But in Python, because most of Python's data structures do not require us to classify or pre-qualify the variable, like here we just wrote int array. But if we were, let's say, working with C, we would have to write int space the variable name to tell the compiler that this variable is an int. But that is something that Python does on its own, so we won't do that. But because now we're working with arrays here, we need to immediately uh, basically tell Python exactly what sort of data would be going in the array. So for that, the first argument is ni. The I telling that this array would be completely made up of integers. We can use C, so on and so forth. You can look at the documentation for more detail. But we have 2 arguments when we call the array function to set up the array. What is the type of data type? That's the first argument, and the second argument within the square brackets is the array itself, just like the list. Second argument is the list that you defined previously. Um, but the first argument is important here because we pre-qualify exactly what sort of data would be held within these within the square brackets of this array. Now, if you want to access elements within the array, just like list, um, it is zero indexed. Just like anything in computer science, it's zero indexed. So we want to access the element is saved at index number 2. So again, variable name, square brackets, index number, which in this case is number 3 again. So the output is 3 when we are indexing it at 2, as you can see on line number 7. Then we want to add an element to the array. Just like the list, we use the pend function, and it behaves exactly like the pend function behaved in the list, as you can see on lines 10 and 11 here. And removing the elements is also exactly the same as the list element that we discussed earlier before. We use the remove function, and the int that we want to remove, and it removes that specific int, as you can see on line 14 and 15. That pretty much wraps up exactly how you can use arrays and how you can leverage them in Python, as well as how you can do the same for lists in Python. So as we're wrapping up this video, it is important to note that arrays in Python are less commonly used than lists. Lists are more versatile and widely used in various scenarios. Arrays provided by the array module are more specialized and can be more efficient for numerical computations when working with large datasets due to their fixed type and memory layout. Again, you just need to understand this distinction on when you need to use arrays and when you need to do lists. You don't need to go too deep into exactly uh, the reason of the efficiency on numerical computations in the case of arrays. You just need to understand, as a rule of thumb, use lists for normal computation processes and use arrays in Python when you're dealing with numerical computations within your software. And with that, we can wrap up the our topic on array data structure in Python. Before we wrap up our video, George, do you have anything to add at the end?
I know. I think you did a great job explaining the concept. Just like and subscribe, and in the comment section, please let us know what other videos you would like us to make content on. That's all I have, Muhammad.
And with that, we'll see you in our next video.